Hello everyone, welcome back to another AP Physics practice problem video. In today's video, we're going to be going over question 5 from the MIT AP Physics 1 workbook. That will be in the description for you guys to access. So let's go ahead and do the question. It says, a body moving in the positive x direction passes the origin at time t equals 0. Between t equals 0 and t equals 1 seconds, the body has a constant speed of 24 meters per second. At t equals 1 second, the body is given a constant acceleration of 6 meters per second squared in the negative x direction. The position of x of the body at t equals 11 seconds is, and then we have our answer choices. So what I would recommend doing is drawing out a diagram to help you understand what's going on in the problem. So we can go ahead and we can here and draw it out. So we can see that here is at t equals 0 seconds. And here we can have t equals 1 second. And over here we can have t equals 11 seconds. So at t equals 0 seconds, we can see that the object has a constant velocity of 24 meters per second. So here it moves 24 meters per second. And we can see that the amount of time during 0 seconds to 1 second is 1 second. And since we can see that this travels 24 meters per second, we can safely say that this is 24 meters right here. And then for t equals 11 seconds, we can go over here at the problem, and then we can see that at t equals 1 second, the body is given a constant acceleration of 6 meters per second squared in the negative x direction, meaning that from 1 second, we're going to be given an acceleration of negative 6 meters per second squared due to it being in the negative x direction. And here is where we would use our AP Physics equations. So the equation we're going to be using in this situation is going to be our delta x is equal to x initial plus v initial times t plus 1 over 2at squared. Now that we have our equation, we can now set up our variables. So for our delta x, that is what we're actually solving for in this case. So we do question mark meters, and then we have our initial position. We can set that as 24 meters, and then we can set our v initial as 24 meters per second, and then we can set our t is equal to 10 seconds due to there being 10 seconds between 1 second and 11 seconds. And then lastly, our acceleration is negative 6 meters per second squared as stated earlier. So now it's pretty simple from here on out. We're just going to go ahead and plug in our known variables into where they belong. So over here we can see our delta x is what we're still solving for. So delta x is equal to 24 plus 24 times 10 plus 1 over 2 times by negative 6 times by 10 squared. Now the next step here is to just combine our like terms. So we would have 24 would stay as 24 plus 24 times 10 should be 240 plus 10 squared is 100 times by 6 would be negative 600 over 2. And this equal delta x. And then we can go ahead and add 24 plus 240, and that will give us 264. And then over here, we can simplify this fraction to being minus 300. And this is all equal to delta x. And then the last step here would to simplify this. So that would be delta x is equal to 36 meters. And this is actually negative 36 meters since we have a bigger negative number. Now, we can go ahead and check this answer with the answer choices available. A says positive 99 meters. That is incorrect. B says positive 36 meters. That is incorrect. C says negative 36 meters. That is also correct. And then E says that it is negative 9 meters. And that is also incorrect, leading us to a correct answer of choice C. I hope you guys enjoyed today's video. If you have any suggestions or any topics that you'd like me to work on, please put them in the comments below. I hope everyone has a good day and good luck with your prepping.